In this video I will discuss with you about only kinetic energy, potential energy and total energy of the particle which executes SHM. Okay. Now first of all, to derive the expression for kinetic energy, potential energy or the total energy, it is very important to remember first of all the formula of the displacement, which is y equals to a sine omega t. Remember, a is the amplitude and omega is the angular frequency and t is any instant, any time t, and y is the displacement. Second formula which you have to remember is that of the velocity, that is equals to r omega cos omega t, or you can say otherwise it is also equals to omega under root of a square minus y square. Remember, a is the amplitude here. Okay, and third formula is the acceleration of a particle which executes SHM. Its expression is acceleration equals to minus omega square y. Y is the displacement. Okay, now now I'm going to derive the expression for the kinetic, potential and the total energy just in this video. Before that, I want to tell the expression which we got for the kinetic energy. It will be kinetic energy equals to half m omega square and then bracket a square minus y square, and the expression for the potential energy comes out to be the potential energy equals to half m omega square and y square, and total energy half m omega square and amplitude square mean a square. Sometimes in the numericals they will ask you about sometimes in the numerical they will ask you that when any particle which is executing SHM, it is half and the midway of the amplitude, it is having half of the amplitude, it is at half of the amplitude. What about its fraction of kinetic energy, fraction of potential energy and fraction of kinetic energy and fraction of the potential energy? Very simple. When it is given y equals to a by 2, you simply use that kinetic energy is equals to half m omega square a square minus y square. There you put y equals to a by 2, and then you divide that kinetic energy by the total energy, which is half m omega square a square. Then you will got that it is about it will be about 3/4, I think so. It will be almost it will be 3/4, I think so. Okay, and then they can ask you what fraction of the potential energy, what fraction of the potential energy of the total energy. Very simple. You apply the formula of the potential energy half m omega square y square and divided by half m omega square a square, and in the numerator you put y equals to a by 2, and then you find from this expression what fraction is the potential energy is of the total when the particle is exactly at the midway of the amplitude. Now one thing is very important. Sometimes you may assume that when the particle is at the midway, it is having kinetic and potential energy is not equal. Is it equal? It's not equal. Okay, you just in this numerical you find what the relation between potential is how much of the kinetic, or kinetic is how much of the potential, and they are not equal. Okay, now the next question, what is the displacement from the mean position? Next is what is the displacement from the mean position where the potential and the kinetic energies, they are equal. You can do very simple calculations, and the result will come out to be y equals to a upon root of 2. Okay. Then there is one more question. If the time period is given to you, time period of SHM is 8 seconds, and they can ask after what time, okay? They will ask you after what time. The energy will be half kinetic and half potential. If they are asking you the energy is half kinetic and half potential, that it means the kinetic and potentials they are equal. Okay, if the kinetic energy is half and potential energy is equals to half kinetic and half potential mean kinetic and potential both energies are equal. And in the last numerical we found that distance from the mean position is a upon root of 2. Okay, now you are having this y equals to a upon root of 2. You apply the formula y equals to a sin omega t. Okay, y equals to a sin omega t, and y equals to a over root 2 is equals to a sin omega, mean omega is angular frequency, that is 2 pi upon capital T, and capital T is given to you the 8 seconds, and into the small t. Okay, y equals to a sin omega t. T means small t, instant time. Okay, you here a cancels out, and then you know that 1 over root 2 it is sin pi by 4. So sin pi by 4 equals to sin 2 pi by 8 into t, and from here you can have the value of small t, any instant time, which comes out to be the 1 seconds. And last numerical is if the mass is given to you the 10 gram, and it is also given in the numericals that after 1 second from the mean position the velocity is 6 centimeter per second, and then they ask you about what is the kinetic energy, potential energy at this point when just after 1 second crossing the mean position where the velocity is 6 centimeter per second. Now it is very simple. We can have the value of the kinetic energy directly, that is half mv square. But okay, but what about how we found the potential energy? If in the formula of the potential energy, you know that is half half m omega square, half m omega square and y square. Okay, and and again how we'll found the value of the total energy. Total energy is half m omega square a square. So first of all we apply a formula that velocity is equals to r omega cos omega t. Okay, we apply the formula v equals to a omega cos omega t. A is the amplitude, that is not given, and velocity is given, omega is 2 pi by t, and time period is given in the numerical, it is 6 seconds. Okay, then small t is the instance time in it is given 1 second from the mean position. So small t is 1 second, right? From here we can found the value of amplitude, and it comes out equals to 36 over pi. Okay, then when we are having the value of the amplitude, then is there no problem for total energy, it is half m omega square a square. When we are having the value of total energy, kinetic energy already we are having, so we can now have the value of potential energy, which is total energy minus the kinetic energy. So from here we can find all the values. Okay, so that's all. Now just go with me for the derivation of kinetic energy and potential energy. Okay, thank you. Today's article is
total energy in SHM.
Total energy in SHM. SHM means
simple harmonic motion.
And what is simple harmonic motion?
That body from main position going to extreme, and then to another extreme, and then back to mean.
Okay, mean to extreme.
Then to another
extreme to another extreme. Then back to
mean.
Mean. mean from here to here, then x to x dash to 0. That is called
simple harmonic motion.
This is one oscillation, right? And time taken to complete one oscillation is called
Time period.
Time period t. So let I take the case that the line is vertical over which the particle is executing SHM. Okay, as the particle is moving, as the particle is executing to and from motion, and it is having the motion. Any moving particle possesses kinetic energy. Our first energy is
Kinetic energy.
Kinetic energy. Kinetic energy is because of
Motion.
energy due to motion. And the particle is moving, so definitely it possesses the kinetic energy. Okay. And what is the expression of kinetic energy? It is half m
v square.
v square. What is m?
Mass.
Mass of the particle which is executing SHM. What is v?
Velocity.
Velocity of the particle. And we already derived the expression of velocity for the particle which is executing SHM. What was that expression? That expression was v is equals to
Omega root a square minus y square.
omega root of
A square minus y square.
a square minus y square. Okay. And in terms of cos expression, if I choose like y equals to a sin omega t, this is the equation of displacement. A is the amplitude displacement equation. Then the velocity equation becomes, what is velocity equation? A omega cos omega t. You have to remember this equation, Always remember this equation. V is equals to A omega cos omega t. Right? Now substituting the value of V, here. Substituting the value of V here, kinetic energy becomes half m a square omega square cos square omega t. Is okay? Half m a square omega square cos square omega t. What it tells, this expression tells us that kinetic energy is a function of time. This m is constant, a is constant, omega is constant. But there is a cos expression, and in the cos expression there is a time. So kinetic energy will change with the time. Now if I substitute this value of V, if I substitute this value of V here, then kinetic energy equals to half m omega square
a square
minus y square. Now this is very important equation. This equation tells us that let this is a mean, this is extreme, this is another extreme. At the mean y equals to 0. It implies what is the kinetic energy at here? Kinetic energy is equals to half m omega square a square, because y equals to 0 from this equation. Right? And what about the kinetic energy here? Kinetic energy equals to half m omega square
a square
a square minus a square minus
y square
because y is equals to a here. What is the value of y here?
A.
Equals to a. So a square minus
a square
a square. A square minus a square becomes
0
so kinetic energy equals to
0
so here kinetic energy equals to at here it is minus a. At here also equals to 0 because a square minus y equals to minus a, again a square minus a square 0. Right? Because y square na. If you put y equals to minus a, negative sign is already there.
yes
Kinetic energy here becomes 0.
0
Kinetic energy is maximum here equals to half m omega square a square. Minimum at here 0. Minimum at here which is 0. Okay, remember that kinetic energy is maximum here, minimum at here, minimum at here. So this is all about kinetic energy. So if I draw a graph, that this is a mean position, this is a extreme position, this is another extreme position, A minus A. So what is the kinetic energy at here from this much? At mean position, half m omega square a square. What is kinetic energy here? 0. What is here? 0. Maximum here. So this is the variation of kinetic energy. So as particle goes from mean to extreme, kinetic energy gone decreasing till it becomes 0. Now it starts increasing, becomes maximum here. Again starts decreasing, becomes 0 here. Again starts increasing and becomes maximum here. So this is all about kinetic energy. Now I am coming to what?
potential energy
Potential energy. Potential energy. What is the meaning of potential energy?
the energy due to position
Energy because of the position. Okay, configuration, position. Okay, let's see how it is. So this is a line, mean position. At any instant, particle is at here. And displacement distance from the mean position is y. Equation of y is equals to a sine omega t. Okay. And what is the acceleration at here? You know velocity equation. A omega cos omega t. What is the acceleration? Acceleration is a omega square minus sine omega t. And a sine omega t is y. This is y. So acceleration is already, we derived it. So it is omega square y. Negative sign shows acceleration pulls the particle towards the mean position. This is acceleration. If this is acceleration, that means particle will experience a force. That means particle will experience a force. Force is mass into acceleration. So substituting A, it becomes m omega square y. Negative sign shows it experiences a force towards the, which pulls it downward, this force pulls the particle
towards mean
position. Now, if the particle to go from P to M by a very small displacement dy, then how it could be? Because the particle is experiencing a force downward in direction towards the mean position. So a force is needed, a force is required. We have to overcome this force. Only then the particle can go from P to M. Right? You have to apply exactly, you to counterbalance this force. Only then the particle can go from P to M. And if the work, that means the work is required to go from P to M. Work is required, na? Against this force. What is that work? dW. That work is? dW is?
Force into distance.
Force into distance. So what is F? How much force we are applying?
Minus.
Not minus. What is the force we are applying?
M omega square y.
Why not negative sign? Because that was towards mean. We are applying a force against this. Mean along up direction. Mean along this direction. So the force is m omega square y and dy. Okay? Now, what is the total work done when the particle, it goes from mean to the point P? For total work done, integrating 0 to y. So, m omega square y dy integration 0 to y. What is y dy integration? That is
V square upon 2.
m omega square y square upon 2. And limits are 0 to y. That becomes 1 by 2 m omega square y square minus 0 square. That is half m omega square y square. So this is the expression of the work done. And whatever the work done, that is stored in the form of potential energy. That is called potential energy. So potential energy at y, potential energy at y becomes half m omega square y square. What it implies? This is the mean position, extreme position. So at here potential energy is half m omega square. That means what about the potential energy at here, at the mean position? What is potential energy at the mean position? How much it is?
0.
0. Because?
Y equals to 0.
Because y equals to 0. And what about the potential energy at here? At the extreme position, half m omega square. You put y equals to a, or here y equals to minus a. So you can put it here plus minus a. So it becomes half m omega square a square. So this is maximum. This is maximum potential energy. So let me draw a graph. Zero here. What about at here? It is maximum equals to half m omega square a square. At here it is maximum half m omega square a square. So graph becomes this is the graph for potential energy. And graph for kinetic energy was so the point where potential is zero, kinetic is maximum. And the point where the potential is maximum, kinetic is zero. So here, kinetic is zero, potential is maximum. Now we coming total energy. Total energy of the particle executing SHM. It is kinetic energy plus potential energy. Kinetic energy was half m omega square a square minus y square. And potential energy is
half m.
I think there is somewhere a mistake.
हाँ जी सर a square minus y square ਇਹ velocity ਦੇ ਕੇਸ ਦੇ ਵਿੱਚ ਸੀਗਾ kinetic energy ਦੇ ਵਿੱਚ ਸੀਗਾ half m omega square a square.
Not y square.
Y square.
This is the expression, no? And what about the potential energy? Half m omega square y square. So open the bracket. Total energy becomes half m omega square a square. Because this is minus y square and plus y square cancels out. So total energy becomes, and total energy remains constant, you know. Total energy is half m omega square a square. It is independent of displacement or velocity. It only depends upon the amplitude and the angular frequency. Okay, total energy because the sum of kinetic plus potential. So if I add the two, the total energy becomes
half m omega square a square.
This becomes the total energy, a line. So this horizontal line, it means potential total energy is not varying. But it is true only if the dissipative forces are absent then. This is true that the total energy remains constant in the absence of the resistive forces. That means there is no air resistance when the pendulum is oscillating. If the pendulum is oscillating, no air resistance, then this expression is applicable. when there is no resistive force. It's okay?